All right. Hello, everybody. Um, Before I get started, I'll give everybody time to enjoy the infinite OBS screen. I know I enjoy it. Look at my little trail of mice. It's like I'm swinging a rope. Okay, let's get started. Welcome. My name's Ben. I'm a QA engineer, and for quite some time now, I have been considering doing a sort of Rust or language authoring related video series. Um, for those of you who don't know, Rust is a programming language that I happen to enjoy. Um, and I sort of stumbled upon this topic, partially out of my interest in DSLs and language authoring, and partially from my experience at work, actually. So what I plan to do is make a video series in which we design, um, implement, and test a DSL for it's a domain-specific language for UI testing, and we're going to do that in Rust. Um, the goal of this particular video, this starting off video, is to sort of give you an introduction into why the heck I would do that, and do a little bit of discovery of how we're going to do that. So I'm going to dive right into it. So I work for a company that owns and operates multiple software products. And I work on a dedicated QA team that's separate from the development team. And recently, we have been transitioning from entirely manual testing, focused on these big test suites and testbed, to having an automated test framework for doing things like regression testing. And our setup for that is very straightforward. It's very much sort of like an industry standard way to go. What we essentially have is we are using Selenium and the Cucumber testing framework to do automated UI tests. And then, this is not really related to this video, but we use a library called Rest Assured to do our API tests, at least on the QA side. The dev team manages and writes their own test suites, of course. So this is the sort of framework that we're using right now. We have a sort of automation utils library, which contains useful things that we want to use for testing on all of our software products. So it has things like our own wrappers around different parts of Selenium, especially to deal with like things that are specific to Angular, because we have Angular a lot of places at the company. We have sort of bindings for interacting with our database or databases, so that we can do things like verify that content on a web page matches what's in the database and stuff like that. And we also have access to some of our automated API testing framework tools, so that we can support our UI tests with API tests. If you've ever worked on big automated test suites, a lot of the time you don't want to do everything manually. You want to do the part of, or I say manually, everything through the UI. You want to do the part that you're testing through the UI, and then you want to do the sort of background stuff through the API so that the test run doesn't take so long. So that's what's in the utils library, and then that library, those arrows are pointing in the wrong direction. That library is basically a dependency for each of our test repositories for each product. So for each software product that our company has, the QA department maintains a repository which effectively serves as a UI test suite. And it's set up in a very straightforward way. We use the Cucumber framework, which is a testing framework where you write these things called feature files in a domain-specific language called Gherkin. and it's not nearly as complicated as it sounds if you haven't used it before. I actually have an example. This is what it looks like. You write these things called scenarios, and you basically write out in English what the steps of what you're testing are. So here our example is we want to do a test for finding some cheese. So given I am on the Google search page, when I search for cheese, then the page title should start with cheese. That's what typical cucumber tests look like. And then from there we sort of expand outward. So that's where we define basically what tests we're capable of running. So each feature file, and really each scenario within a feature file basically constitutes a test that we can run as part of some test suite. And then we extend off of that in two directions. One direction is we have Excel sheets. We have Excel sheets that we bring in as metadata for those feature files for specifying information about those tests. Basically, they serve to let us insert data into the test. You can think of it as like, what's the word for it? Oftentimes when you write, big long test cases, you're running essentially the same test. You're just running it with different inputs. That's what we have Excel sheets for. So we have a test data Excel sheet that basically allows us to register given cucumber scenarios with test suite names. Like we can say this is part of the smoke test suite, or this is part of the regression test suite, or this is part of the load testing suite. And that sort of organizes tests for when we run test suites as part of like CI/CD. And then we also have a data provider Excel sheet. I say Excel sheet, Excel workbook, with lots of different sheets which allow us to basically provide different inputs for the tests that we're running. I want to try and remain as generic as possible when describing this because I probably don't want to be associating with my company too much and saying this is how we do things. So that's on one end. And then on the other end is we have to actually make those tests execute. And so the way that works is you have these feature files and they have each step has some text associated. So like in this example, given I'm on the Google search page, this is a step in the feature file. And we basically map that to a static method in a Java class using regex. So down here on the examples, it'll show you like, here we have this annotation, given I'm on the Google search page, and what it's going to do is it's going to call this method. And we have a running WebDriver, and we're just going to navigate to google.com. And so that's actually how, when we want to define how these tests actually run, what they actually do on the web page, that is a job for Java. And so we have these sorts of step classes, which are basically just a place to put a big list of static methods that map to these Gherkin steps. And then those step classes use created page objects to interact with our software products. So if you've done anything with test automation before, you've probably run across this idea of the page object model. Basically, the idea is you're applying object-oriented design to test automation. And so rather than simply saying, I want to click the element located here, I want to click the element located there, I want to type into this, and then I want to refresh the page or something like that. You build Java classes. You write Java classes that represent the web pages, and more recently, this really turns into the component object model. So the components of your website. And the idea is that you can just sort of have these component objects that let you that describe where each element in the component is located and the ways in which you can interact with it, and then you can reuse those within your test steps. This is, again, all very standard. This is super common throughout the test automation industry as far as I can tell. And it leaves some things to be desired, or at least I've noticed. For my particular team, it leaves some things to be desired. Sore throat. Okay, so I'm going to talk about this. This is Eloise, by the way. This is my miniature schnauzer. She's the one who tore up all the stuff behind me. Okay. So what the heck is my problem? Well, for us, this hasn't really delivered on its promise. The reason we chose this strategy for our test automation is that it comes with this promise that non-technical users, what I mean by that is people who would not describe themselves as software engineers or developers or programmers, can contribute significantly to test authoring. And we get where that's coming from, but in practice, I don't really think we're delivering on this. So if we go back to the diagram, so it's working in theory, right? It is completely possible for the members of our internal QA team, without writing Java, to produce a new test by either providing sort of an entry in the data provider that says, run the same test but with this data. Totally possible. And it's also totally possible for them to author feature files. They can reuse the sort of Java steps that we've created in feature files to create a unique, order in which to do these tests. That's fine. But in practice, something like I would say 90% of the time, if you want to add a new test, you end up dropping into Java for something. There's some sort of functionality that's a part of your test that's not been added to the test suite yet, and so you end up having to write some Java. And I think that, basically, and I'll justify this with the fact that this is so true that our manual QA team members, people who have signed on to do manual QA, are now taking Udemy courses in Java and Selenium, so that they have the ability to contribute to these automated test suites. And so I think it really hasn't delivered on this promise of non-technical participation in the authoring of tests. The follow-up to that, the sort of corollary to that, is if you're going to have to write Java to add to the test suite, then we're really doing a lot of extra effort to author a test. If everyone's going to be, if we're expecting people to use, this fairly complicated typed programming language to author tests, why bother with Cucumber? Why have this sort of glorified reporting facade on top of our test cases? Because it does slow you down significantly. When you go to add a test, you end up changing 4 or 5 files instead of 1 or 2, because you don't just add a step method and maybe make some changes to a page object or create a new page object. You also have to author a feature file, and then you have to make changes to the test data Excel, and then you also have to make changes to the data provider Excel. You have to register the feature file with the appropriate test suites, and then you have to provide data for the test run. So yeah, that's my main problem, and I'm just going to elaborate on that. No, seriously, what are we gaining here? I really don't know. I think we're getting the worst parts of Java with none of the benefits. So one of the things about Cucumber is there's no types, right? Java has types, Cucumber doesn't. And for doing our test authoring in a language without types, that sort of extends to Java. And so we sort of throw away the advantages of Java's type system, right? We have, instead, what we have are a bunch of static void methods that perform an arbitrary operation on a reference to a WebDriver. And then the only real way they have of communicating the result of that operation is they can throw an exception. And what will happen when one of those step methods throws an exception is that the Cucumber feature file will effectively panic and it will stop running. And any sort of dependent tests will be skipped. That's one of the ways in which UI tests end up getting this reputation of being brittle, is that they're written in such a way where one test fails and the rest of the tests still run. So that's not great, right? If we're going to expect people to use Java, if we're going to expect them to learn what is a fairly complicated programming language, and learn about using a type system effectively, we should be getting the benefits of that, right? We should be using it effectively, because right now what's happening is people are having to learn that for the privilege of working around it, for the privilege of throwing away that information. The other thing is that exploratory testing is just totally off the table. People often, I think there's this sort of misconception of a divide between automated testing and manual testing, where you use automated testing to sort of set up reusable test suites that run as part of your CI/CD processes, so that you can, it especially gets used for things like regression testing. Whereas exploratory testing is expected to be fully manual, right? It just makes more sense to have someone open up the web page and reproduce the process manually. But I don't necessarily think that divide has to be there. I don't see a reason why sort of REPL-driven development, or like a sort of at least like a step-through debug type functionality, isn't something that we should be able to do with our Selenium test. It's certainly something that people do with other technologies, things like Cypress. Okay, so is there a technical solution? I'm going to go with maybe. It's entirely possible that automated end-to-end testing is something that's complex enough in terms of the sort of logic involved, that you want to have a software engineer or a developer, whatever it is that those terms mean, do the work, and that the involvement of non-technical, I'm going to use the word stakeholders, it's sort of an empty corporate word, but non-technical stakeholders, that their involvement should really be limited to telling the programmer what they want the tests to say, and then the programmer will then author the tests. I think there's a really solid case for that. End-to-end testing is complicated, and I think part of the reason why we're sort of failing to get the participation we want out of Gherkin is because Gherkin is not as complex as our end-to-end tests are. So like I said, in a Gherkin file, if we look at this, right, here's a sort of scenario, right? If this step fails, all that happens is an exception is thrown, basically, and that scenario sort of exits, and then it goes on to the next scenario. There's no concept of error handling within Gherkin. So what that means is that your non-programmer participants in test authoring, all of a sudden they can't write tests that incorporate this idea of if this fails, then do that. That doesn't exist in the language. Similarly, things like looping and more generic conditionals just don't exist in the language. Whereas they do exist in lots of test requirements. Anyway, yeah. So I think there's a solid case that the domain is complicated enough that you should have programmers use a programming language to do it. In our case, it would mean throw away Cucumber, throw away the Excel files probably, and just write your tests in Java and have the people in charge of it read the Java. I think there's a really solid case for that if your company can afford a senior engineer dedicated to end-to-end testing. And the reason I say senior engineer is not because it's somehow complicated beyond the level of a junior engineer. I say senior engineer because there has to be someone involved who has the authority to take the responsibility for the success of that project, for the success of for the ability of those tests to catch and prevent errors. So yeah, I hear Cypress is cool. Try that. I've looked at it. I've read over the document. I haven't used it at work, but I've looked at it a little bit, read over the documentation. It seems great, but it's certainly something that's meant to be used, as far as I can tell, by developers. You do things like you can hook in your actual components. They have support for like popular JavaScript frameworks and stuff like that. So I think it's certainly something that's meant to be used by developers. I added that in because I knew it would be a comment somewhere on the video. If there was a comment, someone was going to say, "Why don't you just use X?" Okay, so if there is a technical solution, if this is just pessimistic, and there is some sort of solution to this where non-technical people can contribute to test authoring, what does that look like? And I think it looks like a DSL. I think the solution is, can we author a language that encompasses the questions involved in writing a test suite, which has significantly less complexity than a popular scripting language. So I'm going to go through the sort of two main parts of that statement. Can we author a language that encompasses the questions of authoring a test suite? What I mean by those questions is this, right? In our diagram, I sort of broke down what each of these parts of the architecture is used for. So the Gherkin files are basically saying what tests can we run, right? So for instance, in our example, we have a scenario called finding some cheese, and it says it does these three steps. Given I'm on the Google search page, when I search for cheese, then the page title should start with cheese. In our architecture, this test is not guaranteed to execute because we use test data Excel file to register feature files with test suites. So it may or may not be part of the test suite that's running, but we have the ability to run the test if we want to. So that's where this is where we assert what sort of tests we can run. We have the capability of running. Is sort of the collection of those Cucumber steps. It says Gherkin-ish, by the way, because we sort of extend it with some additional functionality. We add sort of Gherkin has some built-in support for variables, but we do it in a little bit of a different way. And we have things like we have sort of environment-defined variables that we can bring in and stuff like that. And then the Excel sheets are basically what tests do we run and what data do we run the tests with. And then the Java, that's what says how should these tests be run. So the Java code is all about receiving a command from Cucumber and saying, okay, this is the equivalent Java code to that command. This is what I want to actually do on the web browser. I want to click this element. I want to type into this input field. Then I want to click this element. Then I want to refresh the page. Then I want to wait for an alert, something like that, So the goal here is sort of, can we author a language that encompasses all of this? can we author a single language that allows us to describe all of this? And there we go. Second part is, can we do it with a language that is less complex than a popular scripting language? And it's important that it's less complex than a popular scripting language, because otherwise we would just use a popular scripting language, right? If the DSL we come up with is basically a clone of JavaScript or a clone of Python, we should just use those. They both have officially supported Selenium bindings, right? But I think my hunch is that this is a good use case for a DSL. That the automated interactions with a web browser is a specific domain that you can accomplish with less complexity than a scripting language. And what I mean by less complexity is maybe you don't need looping, maybe you don't need the ability to extract a procedure, right, a function. Maybe you don't need classes, right? Something looking for a middle ground. Okay, that's the problem definition. That's what we're doing. Now I'd like to spend a very short amount of time talking about how we might go about that, because we're definitely not done with discovery on this. But here's what I've got so far. I'd like to do it with Rust for a few reasons. One, I like it. This is going to take a long time. I like Rust. It's a very pleasant language to work with. I think there's this sort of argument out there that you should use Rust when you have the requirements of a project that you would traditionally use C or C++, but you don't want to deal with C or C++. I think that's a good time to use Rust. I just don't think it's the only time to use it. I find Rust's type system as, more often than not for me, it's a means of expression rather than a means of restriction. I find myself able to express myself better in Rust than I do in a language with a simpler grammar like Python. There are going to be a lot of people who don't feel that way. That's fine. The other thing is that what we're essentially building here, you can think of it as a test running framework. You can think of it as what's a good way to think of it? However you categorize what we're building here, I think the best way to think of it is as an interpreter, right? We're gonna be building a little language, and a language has two parts. It has the actual language itself, and then it has something that runs the language. And that's something that runs the language I think we can call an interpreter. And when we do that, when you build an interpreter, you kind of want to use an efficient language. Otherwise, it's going to get real slow, really quickly. We actually see some of this with our current setup, because what you're essentially doing is you're scripting when you use the Cucumber framework with Java. You're basically scripting with a typed, compiled language. You can totally script with typed languages. That's why they have TypeScript. But Java is a compiled language, and the idea that you could use it to run each of these steps, line by line, and have multiple entry points slows things down a little bit. But anyway, so we kind of want to be efficient, and we want to be smart about how we integrate things. So I think that's the two main reasons why I want to use Rust. Within the Rust ecosystem, here are the things I'm looking at. For Selenium, I'm going to be using the 34 crate. 34 is an excellent crate. I've used it before at work. I have automations, not test automation, but sort of like RPA style automations that use the 34 crate. And it's not your standard Selenium bindings for a language. It doesn't stick to the same script. For that, you could go down to the crate that 34 is built on, called Fantaccini, also an excellent crate. But 34 exposes, it does some creative design on top of that, which I appreciate. I appreciate that that stuff is still happening, that we haven't just settled on this one API and stuck to it. It has a very expressive sort of syntax for advanced queries. This element query syntax. It's great. It's very pleasant to work with. And they've recently added support for what are effectively derivable component structs. So what it will do is you give it a base component, and then you give it sort of locators for the rest of the elements of that component that you'll end up interacting with. And then it will handle sort of resolving variables, checking, what it will handle resolving whether or not the element is stale or not and stuff like that, so that you can describe your interactions just by implementing the component struct, and then you don't have to constantly requery. There's probably more to it than that. I honestly haven't read enough about this recent edition, but it does look cool. Like, we could do some cool stuff with it. So yeah, I'm excited about that. So we're probably going to be using the 34 bindings as far as our access to Selenium goes, because I do plan to build this on top of Selenium. And then as far as DSL authoring, we have a few options. So I think the sort of glaring approach is to use macros, probably a procedural macro. Rust, as a programming language, has this great macro system. And authoring procedural macros, it can be a little daunting at first, but it's actually pretty straightforward once, do David Tolnay's sort of workshop on it, and you'll get the gist. David Tolnay is a guy who wrote 2 crates that are extremely helpful in writing procedural macros. Called one crate is called Sin, and one crate is called Quote. But basically in Rust, you have the ability to write these procedural macros which operate on on either the token stream or the AST of their input, and then they produce Rust code at compile time. So it's if you've ever worked with like language authoring, if you've ever, as part of a computer science course or just for fun, written a scanner and a parser and an interpreter, you're going to be, and then you start to author a Rust procedural macro, and you use the Sin and Quote crate, you're going to be up to speed very quickly. But it's not necessarily how we want to do it. One thing we have to consider is when we want these sort of scripts to be evaluated. Do we want them to simply be transpiled into Rust code and then for us to execute that Rust code? Or do we want to have like real scripting capability and sort of run these tests actually run them line by line and have the chance to, be a scripting language? And for that, we have RyeScript. Rye is a scripting language for Rust. It's basically a port of, as far as I can tell, Chai, which is a popular scripting language for C++. There's this sort of tradition of accompanying, low-level typed compiled languages with high-level scripting languages. I should say statically typed compiled languages with high-level dynamically typed scripting languages. You have Chai script for C++. For Java, tons of people out there use Groovy. And one of the main reasons behind having these sorts of associated scripting languages is DSL authoring. So Groovy is particularly famous for that. There's all sorts of popular Groovy DSLs, including the Gradle Groovy DSL. If you've ever worked on a Java project managed with the Gradle, you could call it a package manager and a build tool and bunch of other things. If you ever used Gradle with a Java project, the Gradle configurations you write are in a sort of subset of Groovy. It's a Groovy DSL. Another one you might be familiar with is like Ruby has Rake, which is another internal DSL. It's valid Ruby, but it doesn't look like Ruby. That's the sort of thing we're looking at here. Where Rye is, it's similar to what we're looking at here. Rye is a scripting language designed to work with the Rust ecosystem, and so you get sort of an interpreter for it, and you can run scripts through the interpreter, and basically you can sort of compile a optimized AST from your Rye script, and then you can run that from your Rust program. So this may be an option, and they have sort of options for using it as a DSL. Actually, yeah. So for those who actually want their own language, use it as a DSL. Disable certain language features such as looping. Actually, here we've got it over here, right? So for using Rye as a DSL, you can do things like you can remap tokens during parsing. You can disable certain keywords or operators. You disable looping. You can make custom operators, and obviously you have to situate them within operator precedence. And then you can extend it with your own custom syntax, and you get this setup that's very similar to the syntax of authoring Rust declarative macros. So those are the options. As far as what this language is actually going to look like, I think I'm going to be drawing a lot of inspiration from something called TagUI. So TagUI is sort of from an adjacent world. It is a language for doing RPA. It stands for Robotic Process Automation. It's a fancy way of saying we want to interact with UIs. It's out of a sort of organization called AI Singapore, and you can see here it's very straightforward. If you want to go to a website, you just type the URL. If you want to type into an element on a web page, or if you want to type into an element on a web page, you give it the locator and what you want to type into it. TagUI takes this really cool strategy for locators, where instead of having to pick a locator, it has a sort of locator precedence. So you can give it the text of your locator, and it'll be like, is this an ID? Is this a name? Is this a tag? Is this an XPath? That sort of thing. Is this a CSS locator? And it makes it a lot easier to locate web elements. It makes it like when you're writing, you don't have to think so hard. This is what we're going for. We're going for a very straightforward, simple syntax for authoring tests, but we want it to be a little bit lower level, a little bit more powerful than the Gherkin language. Because remember, the problem we were running into with the Gherkin language is that in order to contribute anything meaningful, you have to write Java. And so I feel like there's a middle ground that we're missing. And so what we want is for people not to have to learn Java to actually add functionality to what web pages can be automated and stuff like that. If you may have used TagUI before without knowing it, it was sort of, you can use it from Python, and it used to be called TagUI, but now it's called RPA for Python. This is just basically bindings to TagUI. If you've ever used this Python package, RPA for Python, you've used TagUI, and you can see it's this very straightforward API. There's not a lot of indentation going on here, right? It's command, 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 and I think that's what we're going to go for. So I guess that's pretty much the end of the video. I will update you in the next one. Bye.